All right, so I'm recording. All right, so we have this circuit, two switches, a D for data and a C for a clock, leading into a 7474, a latch or a flip-flop. And then there are two outputs, Q and Q tilde or Q prime, the opposite. I'm just going to look at the Q, and the Q, the other one is supposed to be the opposite. And I'm going to go through this sequence of clock and data inputs and figure out what the Qs are. So it was 0 and 0. I'm going to turn it on. And so the Q was 0. And then it has me flipping the D switch high. So I flip the D switch high and Q remains 0. And then it asked me to change the clock, the C, to high, and then the voltmeter changed, so that became a 1. And now it's telling me go back and make the data low, and it remained high. And then make the data high, and it remained high. And then make the clock low, and it remained high. And then make the clock high, and it remained high. And then make the clock low, and it remained high. And then make the data low. Oops. Data low, and it remained high. And then make the clock high, and it went to low. And then make the data high, and it remained low. And then make the data low, and it remained low. Make the data high, it remains low. Make the clock low, it remains low. Make the clock high, and it flipped to a 1. Make the data low, it stayed a 1. Make the clock low, it stayed a 1. And then make the clock high finally. And it went to 0. Okay. So that's what we have so far. So now I can make, I've done my simulation. It was important in my simulation to never turn off the power or restart the simulation because we're dealing with memory, and memory is volatile. And now I'm just going to make this bigger so we can focus on it. This is the output. The Q primes are just the opposite of Qs. They're boring. Okay, now let's figure out the type. So we're going to focus on the main output Q. And when Q changed, we know some writing occurred, and I'm going to call when a 1 was written a set. And then the next time it changed down here, it changed to a 0. So I'm going to call that a reset. And it changed here to a 1. So I'm going to call that a set. And it changed down here on the last one to 0. And I'm going to call that a reset. And now I'm looking for the pattern of when does writing occur and see if I have some consistent pattern. So if I had a 7475 instead of a 7474, that input, instead of being called a clock, is called an enable. And then when enable is high, that's when you write. But that's not what's happening here. Because writing means that the Q, the output, is going to be equal to the data, the input. You're writing the data. And so we can see here at this position here that this is not an enable. This is not when the clock is high, I write the data, because then I would have written as 0. So that's not what's happening. So I need to see with these 4 that I know I have. Let me color them in. These 4 I know I have, like, what is the pattern? Turn off the simulation. So one thing we see is that when it changes, Q changes to D. It does seem to be a writing of the data. It's not simply when the clock is high. That there were counterexamples of that. There were times when that was sort of not the case. So we know it's not that when the clock is high. We know it's not when the clock is 0. So it just didn't swap over to be 0 instead of 1. So it's not when the clock is 0. It's not when the clock is 1. It's not controlled by the level. The only other thing in a sort of a simple binary clock of, you have 0 and you have 1. The alternative to a level is an edge when it changes from 0 to 1, or when it changes, which is a positive edge, or when it changes from 1 to 0, which is a negative edge. So we look again at these things I've shaded orange, the time I know that I've written, and we observe now that we have this is at a positive edge. When 0 is becoming 1, that's when writing seems to occur. That's the pattern. Now we have to look in other places where the pattern occurs and see if it's consistent. Are there any other positive edges? Here's a positive edge, a 0 going to a 1. And it is consistent because Q is equal to D. I happen to already have a 1, but that doesn't mean I can't write a 1 on top of it. So this would be consistent with a set. And do I have any other? That's my only other positive edge. Did anything happen on the negative edge? I guess we should ask for complete consistency. So where is a negative edge? A 1 going to 0, a 1 going to 0, a 1 going to 0. Here I have a 1 going to 0, and the D and the Q are not the same. So we're not writing on a negative edge, but we do seem to be writing on the positive edge. So this was the other positive edge, and I'm going to call that a set. The first one, I'm going to say I don't know what was happening, because usually if I'm holding or something, I'm coming from another, if I'm holding, I have something coming in, and so I'm not sure what's going on here. I'm just going to punt and not call it anything. And everything else is a hold. Everything else, I'm just holding what I had. Hold, 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 down, all the way down, hold. And I'm getting tired already, so you can see the rest of them are holds. So this was positive edge triggering. We did the simulation, we saw when it changed and what it changed to, and then we sort of looked for the pattern of the changing. And with a simple binary clock, you've got level 0, level 1, positive edge, negative edge, and you can have combinations. You could have both positive and negative edge. All right, that's what I wanted to show here.
The previous one.